So now in this video, we're actually going to look at, I'm actually kind of remaking the last video I did. But to begin with, we have a 555 timer wired in astable mode. So I did a step-by-step build of this particular circuit a number of videos ago. But in any case, it's astable mode, which means the output keeps going high and low repeatedly. And it's going to keep doing that as long as we provide power. What is setting the timing though, in this case, we have the capacitor, 470 microfarad capacitor, and a light dependent resistor is doing most of the timing that you see there. So if I get the light dependent resistor darker, it has more resistance, it's taking longer for a given value of capacitance. Get a bright light on it, and it flashes faster right there. And a smaller value capacitor will make it flash even faster. We'll look at that later. But in any case, main thing is we don't have to use an LED. We could use a speaker at the output. So last video I didn't do this. I should have done this. I should have taken a capacitor. So when you use a capacitor in this way, it's called a coupling capacitor. So if we want to put a speaker to the output of there, it's really important that we have this capacitor. We'll look at why. But for now, the main thing is we can take a speaker. And so one thing to note, it's an 8 ohm speaker, so it's very low resistance, and it's rated for half a watt according to that. And so I'll put the blue probe there too, or the blue jumper. I just took alligator clips, so I clipped the terminals. One does have a plus, the other a minus, so blue to minus. And I have these breadboard jumpers. I just crimped with a crimping tool the alligator clip to the jumper there, and had to be careful. But in any case, I'll go to the output of the 555 timer, and actually I didn't go to the output. There we go. I accidentally plugged it to the trigger pin, which is also connected to the threshold pin and the capacitor. But in any case, there you can see. Now we have that I have it to the output. It clicks whenever the LED flashes, and actually when the LED turns off in addition. So this is what I should have done, and we will look at the power supply. You can see current's holding pretty steady, so there's a lot of different changing voltages and current. Sometimes the capacitor is charging, and then sometimes it's discharging, and current going through the resistor there is pretty steady though. It gets pulled to ground the way it is, but then the load is being powered at times. But as you can see, current's not really bouncing around right now, and this is what we want. Now we're going to look at a problem. So I did look at this in the last video, but that's all I had to do to solve the problem, and I didn't think of it while I was making the video. But now, one thing before I continue, I have current limited from the power supply here to a safe value for the output of the 555 timer. Hopefully also to a safe limit for the speaker. It's at 0.5 watts. We're dealing with 5 volts. And so we don't want more than an amp of, or actually half an amp, a tenth of an amp right there. So that's actually our power limit. So I'm just quickly doing the math in my head, so it's getting a little off. But in any case, we're going to look at what happens if instead of a coupling capacitor, I just put this directly to the negative rail. So there you can see the output is going haywire right there, and we're going to make an even worse situation. So that was already a problem. Let's look at that first. So we'll go to voltage. The reason why the timing changed, you can see that the power supply voltage is bouncing around. That's because, well, the output's high, it's actually trying to get more than 100 milliamps of current. But since this is limited to 100 milliamps of current, it has to lower the voltage so that the given load, this whole circuitry, stays at 100 milliamps of current. It actually has to lower the voltage. And this 555 timer depends on the voltage at the rail for setting the high and low output, and based on the capacitor value. That's why I got thrown off. So that's topics for other videos. But the main takeaway is the power supply had to lower voltage to limit current, and because we have the current limited, and so it threw off the timing majorly, as you can see there. So that is one problem. Also, we don't need all that current. The speaker was making the same noise, other than the speed changed because we threw off the timing. And so with the coupling capacitor, a lot less current is being used. And the reason why is because capacitors, they pass alternating current. That's actually what's happening. It's charging when the output is high. It charges, and once it gets done charging, it stops current from flowing. It just does. And then as soon as the output goes low, then it discharges. So you get a click when the output goes high, and then a click when the output goes low. And so the speaker, it's going high, back to the middle area, and then low, back to the middle area. The way that we have it here. When I put the capacitor directly to the negative rail in some way, then it goes high when the output goes high, and current keeps holding the cone in position until we get a low signal. Then it goes back to the middle ground. So it's not doing alternating current, it's just turning on and off and going back and forth. But while it is on, current is just steadily flowing through there. So we got quick pulses, so it's not holding a steady current very long. It does go low, but in this case, if we yank the capacitor there, and now we look at the current being output, now you can see we have a steady 100 milliamps of current going through there. And I think I may have already damaged the speaker. It's making weird noises a lot more than it used to. But in any case, that's okay. That's what these videos are for learning. This video is a what not to do video for the most part. So in any case, we yanked that capacitor. And since I yanked this one, of course, we can control the speed of the flashing, not only with the light dependent resistor, but with the capacitor. So there is a 47 microfarad capacitor. This is flashing about 10 times as fast as it did with the 470 microfarad. But still, the timing is ultimately depending on how much light. That's the biggest variable, but also the capacitor value. And we can attach the coupling capacitor and listen to that tone. So the last video I did, I was using a transistor to power the speaker, so that didn't depend on the 555 timer, and also I used higher current, and we did okay with that. It was the wrong way to wire it, but in any case, when I pulled this capacitor, and again, you don't want to do this if you don't have a coupling capacitor, because current will just continuously run through the speaker. But right now, the capacitor charged, current stopped running, and current can keep running through the LED normally, so that's okay for the LED. We're going to take a 0.0 or a 0.1 microfarad. So this is 470 microfarad. It's 4,700 times the capacitance of this 0.1 microfarad. But in any case, I'll leave the speaker plugged in, and it's going to be a, there we go. It's a high-pitched, annoying noise, and so I'll actually pluck that pretty quick. But it's not near as loud as it was in my other video, my last video. And so I think the smaller value capacitor that you use, the less loud it will get. So let's try this higher value capacitor. And again, these are electrolytic. You have to make sure the negative side is, the negative side of the capacitor is towards the more negative side of the circuit. You don't want to reverse charges. There we go. Let's see if this is louder. No, okay. It's not as loud, but that was, I think, insanely loud. We'll see how it sounds when I edit this, because the camera picks up noise of pretty much everything a lot better than, for the most part, what I can here, so it picks up some noises and drowns out other noises. But in any case, that was extremely loud and annoying. In the last video I did, I didn't realize how loud it was till I edited it. I didn't realize you could barely hear me. But in any case, that was another learning experience. So I'm new to audio electronics, and you know, I've studied it. This stuff isn't confusing for me, but while I'm making videos on the fly like this, I run into stuff that I wasn't prepared to explain. And I think it over afterwards, and I can pretty quickly figure out what went wrong. But in any case, hope you still enjoyed the video. So I'll do updated videos on these topics later on. The main point of this one was make sure you have a coupling capacitor. And I was worried about the power needed by the speaker, but when you have the capacitor here, you really don't need much power. And so we'll actually, before I cut this off, look at why. So right now the capacitor here is charging and discharging. We'll remove the speaker, but what we're going to talk about is the basics of a capacitor passing alternating current but blocking direct current. So just with this schematic, you can see here that when the LED is on, this switch here, this discharge pin, is not discharging. It's open, and so current can't go that way. It goes through the resistor, in this case through a diode, and then charges the capacitor, because the light dependent resistor has a lot more impedance. It's blocking current more than the diode. So the capacitor quickly charges through that resistor, and if the resistance gets low enough here, it gets bright enough, then it's going to go through there pretty easily. But in any case, it charges. So now let's imagine we don't discharge it. What's going to happen is that the capacitor is going to keep charging till the capacitor and the diode, in this case, because they're in series, until their voltage equals the voltage that is charging them. So it's going to stop taking in current. It'll have 5 volts across here, 4.4 there, about 0.6 there, approximately, for a total of 5 volts. So 5 volts going to 5 volts is no voltage difference. So there'll be no push through the resistor to charge the capacitor anymore. So that's why direct current does not pass through a capacitor. It does charge for a brief period of time, but then once it charges, that's it. It's done. Unless you raise the voltage, current won't flow anymore. Now, in this case, the capacitor discharges. So sometimes it's charging, sometimes it is discharging. As far as the capacitor is concerned, there's an alternating current. Current's going one way or the other, like that. The current is still limited by the value of the capacitor. So a larger value capacitor at a slower charge and discharge can pass more current than a smaller value at slower paces. But faster paces, a smaller value capacitor may not charge all the way. But this is going slow enough where our coupling capacitor through the speaker completely charged and then stopped current. So pretty much instantly, but it was still fast enough for the speaker to make a noise. In this case, a click or a tone. And then it discharged. And so it could let enough current to make noise for the speaker, but no more current than it needed. So just a small amount of current charges it and discharges it, but that's all the current we needed for the speaker. But the speaker does not limit current, only at this 8 ohms right there. So high current can flow if you don't use a coupling capacitor. So that's really it for this video. Thanks for watching. I will see you in the next video.